The Eerie Silence, an expert analysis of why we haven't found aliens. The profound silence of the cosmos is a disquieting mystery. In a universe teeming with billions of galaxies, each harboring billions of stars, the apparent absence of extraterrestrial intelligence is a paradox that has captivated and confounded scientists for decades. This cosmic solitude, famously encapsulated in physicist Enrico Fermi's simple question, "Where is everybody?" has spurred a range of compelling and, at times, unsettling scientific theories to explain why we have yet to find any evidence of alien life. At the heart of this enigma lies a stark contradiction: the high probability of extraterrestrial life's existence and the utter lack of any observational evidence. The sheer scale of the universe suggests that Earth is unlikely to be the sole cradle of life. Yet, despite decades of searching, our cosmic neighborhood appears barren. This has led experts to propose a number of sophisticated and thought-provoking explanations, each offering a unique lens through which to view our apparent cosmic isolation. The Great Filter, a universal bottleneck to intelligent life. One of the most profound and debated explanations is the Great Filter hypothesis, first proposed by economist Robin Hanson. This theory posits that there is at least one incredibly difficult and perhaps insurmountable step in the evolution of life from a simple origin to a technologically advanced, spacefaring civilization. This filter could be any number of developmental hurdles that all or nearly all life in the universe fails to overcome. The critical question is where this filter lies in the timeline of life. If the Great Filter is in our past, it suggests that humanity is exceptionally rare for having successfully navigated it. Potential past filters include the initial spark of life itself, known as abiogenesis, a process that biochemist Nick Lane argues is a profound mystery. The transition from simple prokaryotic cells to more complex eukaryotic cells, a pivotal moment in Earth's history, is another candidate. Astrobiologists Dirk Schulze-Makuch and William Baines have argued that while many evolutionary steps seem likely given enough time, the rise of technological, human-level intelligence could be a major filter. Conversely, and more ominously, the Great Filter could lie in our future. This would imply that many civilizations reach a similar technological stage to our own before succumbing to a universal challenge. Potential future filters include self-destruction through nuclear war, catastrophic climate change, or the uncontrolled development of artificial intelligence. A 2024 study by Michael Garrett suggests that the rapid development of artificial superintelligence, ASI, could be a great filter, with a civilization's longevity, L, being less than 200 years after its emergence. This view is echoed by other experts who warn of the existential risks posed by advanced AI. The Rare Earth hypothesis, a privileged planet. Another prominent theory is the Rare Earth hypothesis, which contends that while simple microbial life may be common throughout the universe, the emergence of complex, intelligent life requires an incredibly specific and unlikely convergence of astrophysical and geological conditions. This hypothesis stands in direct opposition to the principle of mediocrity, which suggests that Earth is a typical planet orbiting a typical star. Proponents of the Rare Earth hypothesis point to a long list of factors that have made complex life on Earth possible. These include our solar system's stable orbit within a galactic habitable zone, far from the dangerous radiation of the galactic center. The presence of a large gas giant like Jupiter acts as a cosmic vacuum cleaner, deflecting potentially devastating comets and asteroids. Furthermore, Earth itself possesses a unique combination of features crucial for complex life. A large moon stabilizes our planet's axial tilt, preventing extreme climate fluctuations. Plate tectonics, a relatively rare geological phenomenon, plays a vital role in regulating the climate and creating diverse habitats. The presence of a strong magnetic field generated by a molten core shields the surface from harmful solar radiation. The precise timing and abundance of oxygen in our atmosphere also appear to have been critical. Critics, however, argue that this hypothesis may be too anthropocentric, failing to consider the possibility of life evolving in environments vastly different from our own. The silence of the cosmos, communication and choice. Beyond the physical and evolutionary barriers, the silence could also be a matter of communication breakdown or deliberate choice. The vast distances between stars present a formidable challenge to interstellar communication. As of 2025, our most sensitive radio telescopes would struggle to detect non-directional signals from even the nearest stars. Advanced civilizations may be using communication methods that we are not yet capable of detecting, or they may simply not be broadcasting in our direction. Moreover, sociological and psychological factors could play a significant role. The zoo hypothesis suggests that advanced extraterrestrial civilizations are aware of our existence, but choose to observe us from a distance, much like we observe animals in a nature reserve. This non-interference policy would allow for our natural development without the disruptive influence of a more advanced culture. However, critics point out the difficulty of maintaining a unified, galaxy-wide policy of silence for millions of years without any single civilization or individual breaking ranks. A more unsettling explanation is the dark forest hypothesis, drawn from the science fiction novel of the same name by Liu Cixin. This theory posits that the universe is a dangerous place, and the most rational survival strategy for any intelligent civilization is to remain silent and hidden. Announcing one's presence could invite destruction from a more technologically advanced and potentially hostile neighbor. In this dark forest, every civilization is a silent hunter, and the first to reveal itself becomes a target. While this theory offers a chillingly logical explanation for the cosmic silence, its plausibility is still a matter of intense debate among scientists. The continuing quest for answers. The search for extraterrestrial intelligence, spearheaded by organizations like the SETI Institute, continues to evolve. Scientists are developing new techniques to search for technosignatures, evidence of technology that could indicate the presence of an advanced civilization. The SETI ellipsoid strategy, for instance, focuses on searching for signals that may have been broadcast in synchronization with significant galactic events. This ongoing quest, coupled with advancements in our understanding of exoplanets and the conditions for life, may one day provide a definitive answer to Fermi's profound question. Until then, the eerie silence of the universe remains a powerful reminder of our own unique and perhaps fragile existence. The real reason we haven't found aliens yet may be a complex interplay of all these factors, or it could be something entirely beyond our current comprehension. The continued exploration of these possibilities is not just a search for others, but a deeper exploration of ourselves and our place in the grand cosmic narrative.